This is how you set up a forming simulation to predict the thickness of the glass bottle using Elfen gd3D. For forming projects, 4 separate files are required: the blank mold, the blow mold, neckring, and the plug or plunger depending on the process type. The last part of the file name must have an identifier, and they have to be aligned to the neckring line and center line. As this is a round bottle, the user only needs to prepare the right-hand half of the drawings, and the other half will be drawn automatically when imported in Elfen GD. The same requirements applies to non-round bottles, where they have to be in 4 separate files and each in with an identifier, and aligned to the neckring line and center line, the only difference being it has to be fully surfaced. It is important to note that threads and details will affect the simulation time, so it is best practice to simplify them. Follow the geometry requirements outlined just now and make sure that units are in millimeters. Now export them into IGs or DXF format. They are now ready to be imported into Elfen gd3D. Now in the software, navigate to Furnace in the Forming section and select the material properties for this project. A predefined glass mix is chosen in this example. However, a viscosity calculator based on oxides is provided if required. Now create a narrow neck press blow line by selecting Add Line, and navigate to Geometry and import the geometry prepared. Provide the information on tooling position defined by initial plunger position and final plunger tip baffle distance. The information on the gob is characterized based on gob weight, which calculated as the volumes, and increment crown position and edge, which determine the shape of the gob. The crown position moves the tip of the gob, forming the crown, and the crown edge moves the edges, which allows further refinement of the gob shape. Now navigate to Process Details and define the pressure or force data in the forming process. Now define the temperature of the gob and the tools. The tool temperature can be either defined as a uniform temperature or a specified temperature distribution. The default temperature for mold temperature is used. Finally, navigate to Machine Timings and define the machine speed and event timings. These inputs can be obtained directly from an IS machine. To run the simulation, navigate to Simulation Controls and press Run Simulation. The software will generate a data file and start the simulation. The only thing to do now is to wait for it to complete. Once the forming simulation is completed, let's assess the result. The default view consists of 2 main plots, a cross-sectional plot and a thickness distribution graph. The user has the option to scroll through the forming events or look at different section angles. The primary result the user is interested in is the final thickness of the bottle, which can be used to make decisions on the mold design or machine timings.